Download this code from codegive.com, link in the description below. Analyzing and repairing compilation errors, a comprehensive guide, with code example. Compilation errors are the bane of every programmer's existence. They signify that the code you've written violates the rules of the programming language and cannot be translated into executable instructions by the compiler. While frustrating, these errors are invaluable. They act as a safety net, preventing you from deploying potentially buggy or unpredictable code. Mastering the art of analyzing and repairing compilation errors is a crucial skill for any developer. This tutorial will delve into the process of understanding, diagnosing, and resolving compilation errors. We'll cover common error types, explore effective debugging strategies, and provide practical examples to solidify your understanding. While the examples will primarily be in C++, the principles discussed are applicable to most compiled programming languages, C, Java, Go, etc. Understanding the compilation process and error types. Before diving into specific error types, it's essential to understand the stages of compilation. 1. Pre-processing *. The stage handles directives like include and macro expansions. It prepares the code for the next stage by including header files and substituting macros. 2. Compilation *. The stage translates the pre-processed code into assembly language. The compiler checks for syntax, semantic, and type errors. If errors are found, the compilation process halts. 3. Assembly *. The assembler converts the assembly language code into machine code, object files. 4. Linking *. The linker combines the object files generated from compilation with any necessary library code to create an executable file. Compilation errors typically occur during the compilation stage itself. These errors fall into several broad categories. Syntax errors. These are grammatical errors in the code, violating the language's syntax rules. Examples include missing semicolons, unbalanced parentheses, and incorrect keywords. Semantic errors. These errors occur when the code is syntactically correct but doesn't make logical sense. Examples include using a variable before it's declared, calling a function with the wrong number or type of arguments, or assigning a value of the wrong type to a variable. Type errors. These errors arise when there is a mismatch in the expected and actual data types. Examples include trying to add an integer to a string or passing a pointer to an integer where a pointer to a float is expected. Declaration errors. These errors occur when identifiers, variables, functions, classes, etc., are not properly declared before being used. Definition errors. These errors occur when functions or variables are declared but not defined, or are defined multiple times. Include errors. These errors occur when the compiler cannot find a specified header file. Ambiguity errors. These errors occur when the compiler cannot determine which of several possible interpretations of the code is intended. Template errors. C++. These errors are specific to template metaprogramming and occur when a template cannot be instantiated with the given types. 2. Decoding error messages, your first clue. The compiler provides error messages that pinpoint the location and nature of the problem. Learning to decipher these messages is a vital skill. Here's a breakdown of a typical error message, using a GCC/Clang style. Error.cpp*, the name of the source file where the error occurred. In function int main, the function in which the error occurred. Knowing the scope of the error helps narrow down the search. Error.cpp5:5 the line number, 5, and column number, 5, where the error was detected. Often, The actual error is near this location, possibly on the line before. The compiler doesn't always catch the error at the exact point it occurs. Asterisk error, expected, before return asterisk a description of the error. This is the most important part. In this case, it indicates a missing semicolon. Key strategies for interpreting error messages asterisk. Asterisk read carefully asterisk don't skim. Every word can be important. Asterisk focus on the first error asterisk often, fixing the first error will resolve a cascade of subsequent errors. Asterisk consider the context asterisk look at the lines of code surrounding the error. What are you trying to do? What variables are you using? Asterisk search online asterisk if you don't understand the error message, search for it on the internet. Stack Overflow and other forums are invaluable resources. Include your compiler and version in the search query. Asterisk simplify asterisk if the error is complex, try commenting out sections of code to isolate the problem. 3. Debugging techniques, a toolkit for error resolution. Once you've identified the error, you need to fix it. Here are some effective debugging techniques. Asterisk step-by-step compilation asterisk compile your code frequently, even after making small changes. This helps catch errors early and makes them easier to diagnose. Asterisk code reviews asterisk ask a colleague to review your code. A fresh pair of eyes can often spot mistakes that you've overlooked. Asterisk rubber duck debugging asterisk explain your code, line by line, to a rubber duck, or any inanimate object. The act of explaining often reveals flaws in your logic. Asterisk print statements, debugging insert std code, or equivalent in your language, statements to print the values of variables or the flow of execution. This can help you understand what's happening at runtime. Asterisk debugging tools, GDB, LLDB, Visual Studio Debugger. Use a debugger to step through your code, set breakpoints, and inspect variables at runtime. Debuggers are powerful tools for understanding complex errors. Asterisk static analyzers, ClankTidy, check use static analysis tools to detect potential bugs and code style violations. These tools can catch errors that might not be detected by the compiler. Asterisk version control, Git use version control to track your changes and easily revert to previous versions of your code if you make a mistake. 4. Common compilation errors and how to fix them, code examples. Let's look at some common compilation errors with code examples and solutions. Example 1, missing semicolon. Error message, gcc/clang. Explanation asterisk the error message clearly indicates that a semicolon is missing at the end of the declaration of the variable x. Solution asterisk. Example 2, undeclared variable. Error message, gcc/clang. Explanation asterisk the variable y is being used without being declared first. Solution asterisk. Example 3, incorrect argument type. Error message, gcc/clang. Explanation asterisk the function print number expects an int argument, but we are passing a std string. Solution asterisk. Asterisk explanation of the solution asterisk we used std string stream to convert the string 42 into an integer. This involves creating a string stream object ss initialized with the string, and then extracting the integer value from the stream using the operator. We then pass the integer myint to the print number function. Alternatively, if you're confident the string will always be a valid number, you can use std_stoy, C++11 and later. Example 4, missing include header. Error message, gcc/clang. Explanation asterisk the code uses std vector without including the vector header file. The compiler doesn't know what std vector is. Solution asterisk. Example 5, multiple definitions. To compile this example, g++ file1.cpp file2.cpp o program. Error message, gcc/clang. Explanation asterisk. The variable myVariable is defined in both file1.cpp and file2.cpp. This violates the one definition rule, ODR. While the extern keyword in main.cpp correctly declares the variable, it still cannot resolve the multiple definitions that occur during linking. Solution asterisk. There are several ways to resolve this, depending on the intended behavior. Option 1, define in one file, declare in others, global variable. Compile, g++ file1.cpp file2.cpp o program. Option 2, make the variable static, file scope, not visible outside the file. Compile, g++ file1.cpp file2.cpp o program. Asterisk. Explanation of static asterisk. When a global variable is declared static, its scope is limited to the file in which it is declared. This means each file has its own independent myVariable, and there's no naming conflict at link time. In this case, main's myVariable is entirely distinct, and because we define a local variable myVariable within main, it's that variable that is used by the COUT statement. The extern declaration in main doesn't work since the global variable are not visible outside the files they're defined in because of static. If there were a non-static global variable myVariable, then the extern declaration would refer to it. Option 3, encapsulate in a class/namespace. This is the most modern and recommended approach to avoid global variable pollution. Compile, g++ file1.cpp file2.cpp o program. Asterisk. Explanation of namespaces asterisk. Namespaces create distinct scopes for identifiers, preventing naming collisions. Now, file1 myVariable and file2 myVariable are treated as completely separate variables. Advanced topics, templates and include guards. Asterisk. Template errors asterisk. C++ templates can produce very verbose and complex error messages. Understanding template instantiation and type deduction is crucial. Use static assertions, static_assert, to catch template errors at compile time. Tools like clangtidy are also helpful in diagnosing template issues. Asterisk. Include guards asterisk. To prevent multiple inclusions of header files, which can lead to multiple definition errors, use include guards. Asterisk. Explanation of include guards asterisk. The if and def directive checks if the macro myHeader_h is defined. If it's not, meaning the header hasn't been included yet, the code within the if and def block is processed. The define myHeader_h directive then defines the macro, preventing the header from being included again. The endif directive closes the conditional block. 6. General best practices. Asterisk. Write clean, readable code asterisk. Use consistent indentation, meaningful variable names, and comments to make your code easier to understand and debug. Asterisk. Test thoroughly asterisk. Write unit tests to verify that your code works as expected. Asterisk. Use a code editor with syntax highlighting and error checking asterisk. Modern code editors can detect many errors as you type. Asterisk. Don't ignore warnings asterisk. Warnings are often indicators of potential problems, even if they don't prevent compilation. Treat warnings as errors and fix them. Asterisk. Learn from your mistakes asterisk. Keep a log of the errors you encounter and how you fixed them. This will help you avoid repeating the same mistakes in the future. 7. Conclusion. Analyzing and repairing compilation errors is an essential skill for any programmer. By understanding the compilation process, learning to decipher error messages, mastering debugging techniques, and following best practices, you can significantly reduce the time and frustration associated with error resolution. Remember that errors are not failures, but opportunities to learn and improve your code. Embrace the challenge, be patient, and you'll become a more proficient and confident programmer.